What's up, everybody? Moving on to the next question on the test, we have to determine the inverse of each of these functions. So, number one, we got f of x equals x plus 2 over x plus 1. Now, this is a different type of function than perhaps you've seen before. You'll be dealing with these types of functions more so in grade 12. But nevertheless, it is a function, and we can find the inverse of it. It's just the process is going to be a little bit different, a little bit more complex. There's some extra algebra that we're going to have to do. So with an inverse, what you do, switch the x and y's. And then, as you know, you isolate for the y, and that's going to be the inverse. But notice that there's two y's here to deal with. There's not only one to isolate for. So how can we do that? How can we isolate for y if there are two y variables to work with? Well, what we can do is cross multiply. So this x I put over 1. So 1 times y plus 2 is just y plus 2. And then x times y plus 1 would be x bracket y plus 1. You're multiplying it by that whole expression there. And then from here, what you want to do is you want to distribute the x inside the bracket. So we'll have xy plus x on the right side, and then we'll have y plus 2. And then from here, you want to bring all of the terms that have a y with them to one side and all the other terms to the other. So notice we have a y here. So I'm going to take this xy, I'm going to bring it over. So we'll have y minus xy. And then this 2 I'm going to bring over to the right side. So we'll have x, this x here, minus 2. We switch the sign. And then from here, what we could do is we could factor out a y from these two terms, right? Because they both contain a y. And what would we be left with? Well, y divided by y is just 1, and then xy divided by y is just x, right? So we took out a y from both these terms, and we're left with 1 corresponding to this y minus x corresponding to that xy. Took out the y. And then we have x minus 2 still on the right side. And then from here, to isolate for this y, notice that now we have one single y to work with. So we took two y's that we had, right? Notice all the way up until this point, we were always working with two y's, but now we're just working with one. It's way easier to isolate. You just divide both sides by 1 minus x, right? So basically, y equals x minus 2 over 1 minus x. So the inverse is x minus 2 over 1 minus x. Another way this could actually be written is if you brought this y over and this x over, so we isolated for the y's on the right side instead, you would end up getting, we would have what, 2 minus x over x minus 1. Like that. Both of these are the same thing, right? You could just factor out a negative 1 from the bottom here. It would turn into x minus 1, then you could bring the negative up top, and it'll turn into 2 minus x. So this and this, they are the exact same thing. So you may have gotten this as well if you chose to bring the y's over to the right side instead of the left side, right? But again, both of these are the same thing. So inverse for number 1 is x minus 2 over 1 minus x. That is the answer. Or 2 minus x over x minus 1. Both of them are the same thing. Okay, moving on to number 2. We got f of x equals 2 root 3x minus 4. So y equals 2 root 3x minus 4. Same thing. I switch the x and y's and isolate for that y to get the equation of the inverse. So I'm going to divide both sides by 2, so we'll have x over 2 equals the square root of 3y minus 4. Then to get rid of this radical, I'm going to square this, and I'm going to square this here. So distributing the square, x squared and then 2 squared, we'll have x squared over 4, like that, is equal to 3y minus 4. Remember, when there's an exponent, when you're taking a fraction to an exponent, you have to distribute the exponent to the numerator and the denominator. So x squared over 4, and here the radical goes away. And then we could bring the negative 4 over, so we'll have x squared over 4 plus 4 equals 3y, right? Brought this negative 4 over, then divide everything by 3. So we would end up having the y is by itself, and then x squared over 4 divided by 3, that would actually give us x squared over 12. Right? Because x squared over 4 divided by 3, that's like divided by 3 over 1. That's the same thing as multiplying by 1 over 3, right? Flipping that. So 3 times 4, or 4 times 3 is 12. X squared times 1 is just x squared. And then this is just 4 over 3. Let's just leave it as a fraction. If you want to make this look nicer, you could even take this 1 over 12 and put it in front. So we actually end up with a quadratic here. Right? So that there is the inverse of this. So the inverse, if you want to write in proper notation, 1 over 12 x squared plus 4 over 3. That's the answer for number 2. And then moving on to number 3, we got this quadratic, negative 3x squared minus 12x plus 1. Wrote it up here. Now, when you're taking the inverse of a quadratic, I've mentioned this many times throughout the unit, you got to make sure the quadratic is in vertex form, right? Because it's going to be super tough to isolate for these two x's here. Here it was easier because the x's didn't have degrees to them. But here when you have this x squared and then you have this x to the power 1, it's a lot tougher if we're just going to have y squared and then y there. So you got to make sure you put this in vertex form first and then find the inverse. All right? So just be careful when you're finding the inverse of a quadratic. If it's in standard form or in factored form, convert it to vertex and then find the inverse. If it's already given in vertex form, then you can go straight into finding the inverse. It's really easy to isolate for that y after you interchange. So first step, let's put this in vertex form. So we'll factor out a negative 3 from these two terms. This is plus 1. This will be negative 3. This will be x squared plus 4x. Then half of 4 is 2. Squared is 4. So we'll have plus 4 minus 4. This will be plus 1. And x squared plus 4x plus 4. Take out the negative 4 from the bracket. Negative 4 times negative 3 is positive 12. And this is positive 1. And then this ends up being x plus 2 squared. That's a perfect square trinomial plus 13, like that. Okay, so took this quadratic, converted it to vertex form. So now, once we have that, we got y equals negative 3x plus 2 squared plus 13. From here, what we can do is we could just interchange the x and y's now. So x equals negative 3, y plus 2 squared plus 13. And now we could just isolate for that y. So we bring the 13 over, so x minus 13 equals negative 3, y plus 2 squared. Divide both sides by negative 3, so x minus 13 over negative 3 equals y plus 2 squared. Square root both sides. Right, and here we'll have y plus 2, and then bring this 2 over. So we end up with y equals square root of x minus 13 over negative 3 minus 2. Like that. So that would be square root x minus 13 over negative 3 minus 2. That's the inverse. Right? So be careful. When finding the inverse of a quadratic, always make sure first it's in vertex form, and then you can switch the x and y's and then isolate for that y a lot smoother.